Hey guys, in this lesson we would understand what are reaction rates or rates of reaction. We would also understand their types and how to do calculations related to rates of reaction. First of all, let's understand the word rate. Rate means speed. Therefore, if we're talking about reaction rate, that would be equal to speed of reaction. As we know, speed is equal to distance divided by time. Similarly, reaction rate would be equal to change in concentration over time. The other way we can say change in concentration is final concentration minus initial concentration, and the whole thing is divided by time. If you want to write this down chemically, we can write down concentration of A final, always remember the square brackets means concentration, minus concentration of A initial over time is equal to reaction rate or rate of reaction. So finally we can conclude that rate of reaction is equal to change in concentration of A over change in time. This sign delta means change, and A is just a variable. We can use any other variable apart from A here. Now since we're talking about the rate of reaction, and we all know that reaction means reactants give us products. So one thing we have to keep in mind is that for a particular reaction, the rate at which the reactants concentration change, product concentration also change at the same rate. The only difference is that the reactant concentration decreases, whereas the product concentration increases. But both of these things would happen at the same speed. For example, if we have A gives us B as a product, so A is a reactant here and B is the product here. If we want to find out the reaction rate, so we can write it as reaction rate or rate of reaction is equal to change in concentration of A over time is same as the change in concentration of B over time. The only difference is that reactant concentration of A decreases, that is shown with this negative sign, and product concentration increases, and that is shown with this positive sign. But the values of the reaction rates are going to be same for A and B both. Another thing we have to keep in mind here is that in chemistry everything works with moles. So since here both of these have 1 mole, we are comparing them with the same number of moles. If moles differ, then we have to convert them to 1 mole first, and then we can put them equal to each other. We'll be doing these when we will be doing some questions related to it. But for now, we just have to keep in mind that the rate of reaction of a reactant and the rate of reaction of the product is always equal. Reactant concentration decreases, product concentration increases. Another thing we need to know here is that rate of reaction is of two types. One is called the average rate of reaction and the other is called the instantaneous rate of reaction. Average and instantaneous, they both mean change in concentration over time, but an average rate, we will be finding the change in concentration. It could be of the reactant or product, doesn't matter, because we know the reaction rate is same over a period of given interval. For example, if we are asked to find out change in concentration from 1 second to 10 seconds, then we find out the concentration at 1 second, concentration at 10 seconds, and then the average rate would be equal to concentration at 10 seconds minus the concentration at 1 second divided by 10 minus 1. So the numerator represents the change in concentration and the denominator represents change in time. Let's talk about instantaneous rate now. Instantaneous rate is the rate of reaction at a particular time. For example, if we want to find out the rate at exactly 10 seconds, then what we find is called the instantaneous rate. Let's understand this using this example. So the question is, to determine the rate of reaction, a technician determined that the concentration of a substance is 0.25 moles per liter at 0.5 minutes and 0.420 moles per liter at 2 minutes. What rate can the technician find using this information? So we are given a concentration at one time and then we are given another concentration at another time. Whenever we are given two separate times, the best rate is the average rate. So the answer to this question is average rate of reaction. Next is the technician using reactant or product? Now how do we figure that out? We look at the initial concentration is 0.25 and the final concentration at a later time is 0.420. And we compare the numbers. We know 0.420 is greater than 0.25, so that means the final concentration is higher than the initial concentration. If final concentration is higher, means the concentration is increasing. So this is definitely a product, as the product concentration increases in a reaction. Next, they want us to determine the rate of reaction. So to find out the rate of reaction, we just have to use the formula, and because it's product, so we would put it as plus change in concentration of the product over change in time. Now change in concentration of the product is the final concentration of product minus the initial concentration of product divided by the change in time, which is 2 minus 0.5 minutes, and this gives us 0.17 divided by 1.5, which is equal to 0.133. The unit is going to be, this is moles per liter and this is minute. So this is moles per liter per minute. So finally we can write on the answer as 0.133 moles per liter minute. And we have to put this with a plus sign, means this has been derived from the concentration of products. Putting a sign or putting not a sign does not make a difference. Plus here just means that the rate of reaction has been derived from products.